In this video, we are going to be going over various statistics and function problems. This will include finding the mean, median, and mode of datasets, and solving functions with values. Let us get started. So we can start with the first problem. If f(x) is equal to x squared minus 3, what is f(10) minus 4? So we can start by equating f(10) minus 4 to f(6). Now, we can realize that f of anything is basically like a function, and we can put a 6 in our existing function. So 6 squared minus 3 is our problem that we have to solve, which is 36 minus 3. And then that would equal 33. Now let us move on to the next problem. A star B is equal to AB plus 4A minus 3B. What is 9 star 2? So the star is like any symbol, and the 9 and 2 would be A and B. So the star can be like multiplication, division, anything that is in the function. So if we have 9 is A and 2 is B, we can just put those values in this equation right here. So that would be 18 plus 36 minus 6, and that would be 18 plus 30, which would be 48. Equals 48, and this is our answer. So it's basically like any other function problem, just with symbols. Now let us move on to the next problem. Find the mean of 9,812,401, 9,812,407, 9,812,429, and 9,812,413. So, this is a problem with mean, and adding these numbers seems like a very bad solution because it would take a long time to add them. That wouldn't be a good solution. So, let's look at these numbers. What do you notice about them? You can pause the video and think about it. So, I assume we have time to think. 9,812,400 is an every number. So, we can equate the mean to 9,812,400 plus the mean of the last 2 digits. I'll show you why this works. So this number is always there in every place. Now let's move on to how this works. So if 400 is equal to n, then the mean would be equal to n, and then n plus the mean of everything else. So 1, 7, 29, and 13. That would be 1 plus 7 plus 29 plus 13 over 4 plus n. Now, let me show you the reason this works. So imagine n is any variable. In this case, it's 9,912,400. Then, here's how we would calculate mean. Yeah, so the mean, if we included this big number, would be 4n over 4, because there are 4 n's in each one, plus the mean of the last 2 digits. And then the 4's cancel out, so it's just n plus 1, the mean of 1, 7, 29, and 13. So now that we know that, we can move on to solving this. Let me just clean up my board. Okay, so now let's calculate the mean of 1, 7, 29, and 13. And so that's 1 plus 7 plus 29 plus 13 over 4. And that would be equal to, let's see, so 12.5 that would be equal to. Now, and then we just add the n to that. So first that would equal 12.5. And now we have to add n. So that will, yeah, this is without the n. So now 4n plus 12.5. And that would be our answer, n plus 12.5, which would be 9,812,412.5. And that would be our answer. Now we can move on to the next problem. Aaron's scores on 6 tests are 63, 77, 83, 85, 94, and 96. He takes one more test. What are all the possible values of the median of the dataset, including the new test score? So, here is how we do it. We can calculate all the places that Aaron's new test score could be in, and then see in which places it would change. So we can now, let's calculate all the places it can be. So let's call this variable t, the new test score is t. And then wherever I'm placing a line is where it can be. Right. Yeah. There is also less than 63. I did forget to include that. Yeah. And now, so if the t, which is our variable, is less than 83, so we can test this out, less than 63, less than 77, less than 83, then the mean will always be 83. The median, sorry. And that's because there would be 3 numbers on both sides. It's an odd number set, so the middle number is always 83. So that's one value. Now let's move on to the next. If t is greater than 83, oh yeah, I just forgot to write median is 83. And now if t is greater than 83, but now it has to be in the middle less than 85, then and so let me just rewrite that. If t is greater than 83 and less than 85, then what could t be? T would be equal to, the median would actually be equal to t, or 84. Because when t is in the middle, t is the middle number, it is now the median. Now, we have to calculate one more possibility. If t is greater than 85. Now, that makes 85 the middle number with 3 on both sides, 3 numbers on both sides. The median would be 85. So now we just have all our possibilities, 1, 2, and 3. So there are 3 possibilities. Now we can move on to the next the next question. And now we will be moving on to the challenge problem. The challenge problem is, we did this once before. There'll be a problem as a challenge. I will not give the answer in this video. You can comment the answer, and then who are the first 3 people, I'd say, to get it right will get a shout out in the next video. If fa is equal to 2a minus 3, what is the median of the data set containing these 5 values? f3, f4, f6, f9, and f11. And these are the shoutouts: Teresa Guan, Shane Hedire, and Gwyneth K, who correctly answered the last challenge problem. What is the probability of guessing a 4-digit PIN? The answer was 1 over 1,000. And the way you can get this is, there are 10 numbers for each digit in the PIN, 10 number, because 1 to 10. Then we can 0 to 9, not 1 to 10. Then, so there's 1/10 possibility of getting each one right. Multiply the square by 4, and that would be 1 over 1,000. That will be all. Thank you.